I am Anil Kumar and I have compiled some videos to prepare you for calculus. So the heading is Pre-Calculus, and now we'll discuss how to find horizontal asymptotes. The question here is, discuss the end behavior of the rational function f of x equals to a times x to the power of n plus c divided by bx cubed plus d, where n belongs to set of natural numbers. So I've taken kind of a very general question so that we can broadly discuss this and understand. I know most of you know about it, but it will be a good review. Now when we say n is set of natural numbers, that means n is not 0 but 1, 2, 3, 4, things like that. Okay, a, b, c and d could be any rational numbers, which I have not mentioned, but these constants could be any rational numbers, right? Now if you see the equation, the degree of denominator is fixed and it is 3. So we need to find the end behavior of this rational function. It is indeed a rational function since the exponents are natural numbers, right? Otherwise this won't be a rational function. Now, so we have kind of reviewed what a rational function is and how this definition fits well. Now when we say end behavior, what are we trying to understand? We are basically trying to understand what happens to the value of function as x approaches minus infinity or as x approaches plus infinity. So that is end behavior. Now if the value of the function, if the function approaches a fixed value, then we say that y equals to that value is a horizontal asymptote. So that is how we can link horizontal asymptote to this question. But if as x approaches infinity, the function also approaches undefined value or unbound or very high value like infinity, could be plus or minus, then we say that horizontal asymptote does not exist, right? So end behavior, I'm trying to relate it with horizontal asymptote. So that's an important aspect of calculus which we'll look into further details. So let's figure it out that if we are given a general equation like this, how can we conclude about horizontal asymptote? So basically there are three different conditions, and that is when n is equal to 3, or when n is greater than 3, or when n is less than 3. Depending on those three conditions, we have three different kinds of results, right? So here is a proof for it. So let's start with factoring out x cubed. So what do we get? So we have function f of x, and what I will do is I'll factor x cubed out. So if I factor x cubed, what do I get? That's what I'm trying to see now. So from the numerator, if I factor x cubed, I have a here, right? X to the power of n minus 3, right? So x cubed I factored, and this is plus c over x cubed. And in the denominator, since I factored x cubed, I have x cubed here, I'm left with b and plus d over x cubed. So this is what is going to happen if I factor x cubed out. Now of course I can cancel these x cubes, right? So if I cancel x cubes, that is one part, and second part which I'm looking into, okay, let me first cancel them, and then what I get is a x to the power of n minus 3 plus c over x cubed divided by b plus d over x cubed. Okay. Now when we are talking about end behavior, we are saying x is very large number. It could be negative or positive. Now if x is very large number, then what happens to c over x cubed and d over x cubed? Think about it like this. If x is plus or minus infinity, then c over x cubed should be what? I think it will approach 0, right? Very small number. Similarly, d over x cubed will also approach 0, correct? So in that case, our function will reduce to a over b x to the power of n minus 3. So that is going to be the value of the function as x approaches positive or negative infinity, right? So that is what we get, right? So now what we can write here, safe and sound, is, let me just divide this page and let's move on to the right side. So we'll move on to this side from here, right? So we are here. Okay, so what we find here, that as x approaches minus infinity or plus infinity for that matter, then f of x, which is y, approaches a over b times x to the power of n minus 3 in this case. Perfect, right? Now that actually will give you an idea what will happen if n is 3, if n is less than 3 or n is greater than 3, correct? So let's have three different conditions for this. Now the condition number 1, let me write condition number 1, is when n is greater than 3, right? So if n is greater than 3, even if it is 4, right, in that case f of x will be approaching a over b x, right? Now since x is infinity, right, infinitely large, plus or minus, correct, this is also approaching infinity depending on minus or plus, right? So it is approaching depending on whatever large value. So what I'm trying to say is unbound. So it could be plus or minus depending if it is on board, correct? Either way. So it is a very large value. So we say in this case there is no horizontal asymptote, right? The function is approaching or increasing unbound. Okay, so that is one condition. Since it is not approaching a fixed value, we do not have any horizontal asymptote. So we say, well, in this case we do not have horizontal asymptote, right? So let me write horizontal asymptote as HA. Okay. Now condition number 2 will be when n is equal to 3. Now if n is equals to 3, then what happens? Then f of x approaches a over b x to the power of, n is 3 means 0, right? Well, that means 1. So that means it approaches a over b, right? So that means the horizontal asymptote exists, right? So in this case we do have a horizontal asymptote, and the equation is y equals to the value it approaches, which is a over b. So a over b are the leading coefficients of numerator and denominator, correct? So we get that as a horizontal asymptote if the degree of numerator and denominator is same, to generalize, correct? Now third condition is when n is less than 3, right? Now if n is less than 3, then this will be a negative value, right? So in that case f of x will approach a over b x to the power of, if n is less than 3, so it will be some negative number, correct? N could be 1 or 2, right? So it is definitely a negative number. So if it is a negative number, then it means a negative number in x large, that means it is approaching 0. Do you see that? So it is negative something. Let me write this as less than 3 means n minus 3 is negative, right? Let me write n minus 3 itself because it could be 1 or 2. So in that case this is negative. So what we can say is that this value approaches 0. Do you see that? It becomes a over b divided by x or x square. You get the point, right? So in that case what we find is that the value approaches 0, and therefore in this case also we will have a horizontal asymptote, and the equation of horizontal asymptote is y equals to 0 since we are approaching 0, right? Do you understand that point? So, and that's the definition of horizontal asymptote. When x value is approaching positive or negative infinity, if the value of the function approaches a fixed value, then horizontal asymptote exists, and the line y equals to that value is the equation of horizontal asymptote, right? So in all these cases we have seen, if n is less than 3 or equal to 3, we'll have horizontal asymptote. These two cases, right? But if n is greater than 3, we'll not have horizontal asymptote, right? So in general, for any rational function of the given form, if the numerator degree is higher than the denominator degree, horizontal asymptote will not exist. But if numerator degree is same as denominator degree, it will exist, and the equation will be y equals to ratio of leading coefficients. But in case n is less than, or the numerator degree is less than that of the denominator degree, then the horizontal asymptote will be y equals to 0, or the x-axis. So this is x-axis, right? So x-axis will be the horizontal asymptote. If n is less than 3, that means 1 or 2 in this particular case. I hope that brings things together and you understand how to find the end behavior for a rational function, and end behavior at times gives you horizontal asymptote. Great. Thank you and all the best.